So we're going to keep completing the square, and we're going to talk about how to do it when this leading coefficient, this a value, isn't 1, is something other than 1. So before, when that's 1, we just make 1 square. But since that's 2, we have 2x squareds. So really we're making 2 squares, 2 different collection of squares. And so what we're going to do is we're going to say I've got 2x squareds, and these 20x's get divided up evenly between these 2 piles. So notice I'd put 10 of them here and 10 of them here. And with that 10, I can cut it in half and say, all right, I'm going to do 5 and 5. So algebraically, what I've done is I've taken a 2 just out of the first 2 terms, x squared plus 10x. And that 90 is going to sit there. And now notice I'm going to complete the square on both of these at once, but I can just think about 1 square at a time, like, because they're the same. So if this is x plus 5, notice I've got 10 x's, so 20 x's total. This would have to be a 25. So I'm going to add 25. Now I'm going to have to subtract something to offset that, right? But I didn't add just 25, right? I added 25 twice. Everything that's in here is multiplied by 2. So if I add 25, I've added it to both of these piles. I've added it here and here. So I have to subtract 50. So see how it's like 2 times 25. So now I have 2 of these squareds, x plus 5 squared, plus I had 90, I used 50, right? So I'd have some left over. 90 minus 50 is 40. So there's the square completed on that one. Let's do it again with this one. On this one, I have 3 of these x's. So x squared, sorry. 3 of them. And then I would need to distribute that 12 x's to each pile, so it gets divided by 3 as well, right? So I'm going to say this would be the same as 3 times x squared plus, and I'm just dividing the 3 out of here, dividing that by 3. Right, so I have 4, so half of 4 is 2, so this would be 2 and 2, and 2 squared is 4. So to complete just one of these squares, this would be a plus 4. Right, and I've got to compensate for it. I added something, I have to subtract something, the same amount to keep it equal. But notice that 4 gets added into here 3 times, right? So I added 4 3 times, so I actually added 12, so I'm going to subtract 12. This is one of these squares, an x plus 2 square. I've got 3 of them. And then I was already short 5. I needed 12, so I'm short 17. This collection of tiles is these 3 piles of squares minus 17 tiles, right? It's short. This one, same idea. I'm just going to do this one algebraically. I'm going to break this into 5 piles. 30 divided by 5 is 6. Notice it's like distributive property in reverse, right? Complete the square here, so half of 6 is 3. 3 squared is 9. So I add 9. But as you know, that 9 is really worth 5 times 9, 45. So this would be 5 of these x plus 3 squareds. And then whatever this ends up being, negative 2 minus 45, negative 47. And that is how we can complete the square when a is not 1.